So we look up the definition of an autoimmune disease, and we see autoimmune disease. It's when my body is attacking my own tissue. Well, that's not good. So I'm going to ask my doctor, you diagnosed me with rheumatoid arthritis. That's an autoimmune disorder. Why is it happening, doctor? Well, that's an autoimmune disorder, and it's idiopathic, which is Latin for we have no idea. So that's typically the best, the deepest answer that you get, but that's not good enough. Okay, why? So what is an autoimmune disease? Well, I looked it up. It says when your body is attacking your own tissue. Well, let's expand that definition a little bit. It's not your body that's attacking your own tissue, it's your immune system. So either a hyper-firing Th1 or a hyper-firing Th2 response is destroying your own cells. Okay, well that's a little bit clearer. We know that's an immune system killing your own cells, but still why? Well, your immune system, remember I said it does one thing and it does one thing well. What does it do? Kills things. That's what it's supposed to do. So your immune system, therefore, by very definition, is only supposed to turn on against something that it can kill. What are things that are killable that can enter your body as pathogens? We named them: viruses, bacteria, parasites, molds, funguses, right? Living organisms. Those are called biotoxins, living organisms that enter your body. Your immune system is supposed to kill those things. So, if my immune system is healthy, okay, it's a healthy immune system, I will fire a Th1, Th2 response and be able to kill that thing. Most of the time. So, here's the problems. Here's some things that cause an autoimmune disorder. There are some biotoxins, living organisms, mainly bacteria, that have the ability to go inside the cell. Now, bacteria are typically too large to go inside the cell. So you're exposed to them, you breathe them on me, they went into my bloodstream, they're circulating around my bloodstream. As long as they stay within my bloodstream, my immune system should be able to kill them as long as I have a healthy enough immune system. The problem is that there are some things, viruses are small enough to go inside of a cell. Now, if a virus enters a cell, and there's some bacteria that could go inside of the cell, that's the problem with Lyme disease. If there is a virus or a bacteria that goes inside the cell, what happens is your cell puts up this chemical marker on the outside of the cell. In a sense, you can say it's like if you went in to rob a bank and the cashier goes, okay, and she pushes the red button under the counter. And it calls the police and tells them there's somebody robbing our bank. And the police send the SWAT team, surround the entire bank until they catch the robber. Well, your body is much more efficient in waiting out for the robber to come out of the bank. What your body does when a virus enters the cell puts up a marker on the outside of the cell. Your lymphocytes and macrophages will surround that entire cell and destroy the cell, thereby killing the pathogen. It's very efficient. We sacrificed one cell. So what? It was going to die in 6 weeks anyhow, but we killed the pathogen and we destroyed it. However, there are some nasty viruses, Lyme being one of them, that could go inside the cell and disable that marker. So think of it, the teller inside the cell is hitting the red button, but nobody's coming to the rescue. So that pathogen can reproduce. And since we got somebody talking on Lyme today, we'll use another type of pathogen that does that very well. And have you ever heard of Helicobacter pylori, H. pylori? It's a nasty bacterial infection that has the ability to go inside the cell and disable that marker and reproduce. And because they're opportunistic organisms, when the immune response has finally slowed down or died down, it goes outside the cell and reproduces some more. You fire another immune response, it goes back inside the cell and hides again. Nasty things. So, if I have one of those nasty type bacterial or viruses that have the ability to disable the marker inside the cell, my immune system cannot find it and then cannot effectively kill it. So it's constantly firing in a response against this pathogen that isn't very killable because it's elusive. Follow me? So when I do fire a Th1 response, and now it suppresses and I fire a Th2 response, and it hides inside the cell, my Th2 cytokines, the chemicals that are in that Th2 response that are responsible for making antibodies, are now looking for, I don't know what I'm supposed to make an antibody against, and here I'm at the thyroid gland, and so it starts making antibodies against your own tissue. That's what an autoimmune disease is. When your immune system, particularly your Th2 response, is unable to find the pathogen, what we now call the antigen, something that the immune system is turned on against, it's unable to find the antigen that your Th1 system has been constantly trying to fire and kill, it can create antibodies against the tissue that the response happened in. So then I can end up having thyroid antibodies, and then my immune system, my Th1 system, starts firing again, and it starts destroying thyroid cells. Not good. That's called Hashimoto's, or Graves' disease, if it's a hyperthyroid. So that's what the definition of an autoimmune disease expanded is, that when my immune system starts destroying my own cells because the antigen in question was not able to be found, and my immune system, my Th2 side, started to create antibodies against my own tissue, and therefore my immune system, my Th1 cytokines, started destroying my own tissue. That's what an autoimmune disease is.